Good evening, my YouTube viewers. Crystal here. I just wanted to make you another video tonight because I was working on the Big Mart competition question sponsored by Analytics Vidhaya, and I was able to improve my score incrementally. And because I was able to improve the score incrementally using CatBoost, I wanted to make a video to show you what I did. I'm not sure if I ever actually did a video on Big Mart in the first place, so this may be the first video that I've done, but I did actually improve my score with Big Mart. First thing we'll do is we'll read the problem statement that's on the Analytics Vidhaya website for the Big Mart competition question. The data scientists at Big Mart have collected 2013 sales data for 1,559 products across 10 stores in different cities. Also, certain attributes of each product and store have been defined. The aim is to build a predictive model and predict the sales of each product at a particular outlet. Using this model, Big Mart will try to understand the properties of products and outlets which play a key role in increasing sales. Please note that the data may have missing values, as some stores might not report all the data due to technical glitches. Hence, it will be required to treat them accordingly. So that's your problem statement. The first thing I'm going to do is I'm going to copy the web address, and then whenever I finish this video, then what I will do is I will put a link to the web address in the description box, so you can go onto the GitHub account that this program is in and follow along with me. So the first thing we did is we imported the libraries that we were going to be using in Python, and these are Python libraries. I would just like to say that I actually wrote this program in Google Colab because it's free, and it's a lot easier for me to use Google Colab than it is for me to install all of these libraries on my own computer, because you're always going to have to install updates. So Google Colab installs the updates for me. So that's good. The next thing we're going to do is we're going to load and read the data sets. So the first data set that we load and read was on the train file. And let me just check and see. Well, I believe that the data sets are actually loaded in my GitHub account, but if they're not loaded in my GitHub account, then you should be able to load them up on the Analytics Vidhaya website, because they give a sample, a train, and a test file. And when I do my blog post, I will be sure and provide a link to the data sets. So these are your data sets. It's 8,523 rows by 12 columns. So we check our shape, and then we check our info, and then we get a description. We get a description on the numeric columns. And now we load the test data set. And the test data set is 5,681 rows by 11 columns. And the reason why is because the test data set does not have a target or a label. And the target is item outlet sales. So you can either call it a target or you can call it a label. So we check our test shape, we check test info, we check test describe, and now we check the D types, so you can tell you whether the column is an object, a float, or an integer. And now what we're going to do is we're going to check for any null values. So item weight, we have null values. In outlet size, we have null values in both the train and the test file. And the thing that I will tell you is that item weight is a numeric column, and outlet size is a an object. So what we're going to do is we're going to do what they want you to do when you're using CatBoost. So throughout the entire data frame, you replace any null values with neg 999. And what CatBoost will do is CatBoost will identify that and work on it. And I'm going to find out a little bit more about why CatBoost wants to see 999, because this is the second program that I've worked on where they want to see 999 for any missing values. And CatBoost wants to see 999 in both numeric values, numeric columns, and object columns. The next thing we do is we define our X, Y, and X test. So one thing we do is we define a variable called item identifier equals test item identifier. And the reason why is because X is going to be train drop item outlet sales item identifier axis equals 1, and X test equals test drop item identifier axis equals 1. And Y is your item is train item outlet sales. So we're going to drop this item identifier, but before we drop it, we're going to define this variable item identifier, because we're going to need that variable at the very end of the program. And the next thing we do is we split our train setup for training and validating. And so we X train, X val, Y train, Y val equals train test split, X, Y, random state equals 1, test size equals 0.1. And then we check the shape of all of those data sets. And then now what we've done is we've defined our categorical features indices equals NP where x.dtype does not equal NP float 0. So that's just something that we've defined that's part of CatBoost, but I didn't use it and it didn't make any difference, but it's just something that's been defined. And the next thing we do is, because CatBoost is not automatically installed on Google Colab, so we had to install CatBoost on Google Colab. And now what we do is we define our model. So it says from CatBoost, import CatBoost regressor. Model equals CatBoost regressor. Iterations equals 1,000, depth equals 5, learning rate equals 0.1, loss function equals RMSE. And then we fit the model. So model fit X train, Y train, cat features equals categorical features indexes, eval set equals X val, Y val, plot equals true, but it didn't plot it, and print model score X train, Y train. So it goes through all of these iterations. It goes through 1,000 iterations. So we just keep going through 1,000 iterations. And when we did our 1,000 iterations, we've got an accuracy of 60.38% accuracy. And what I will say is, when I tried this algorithm up using the column transformer methodology, I had an accuracy of 77. So I had an accuracy of 17 points higher than the accuracy using this model. But the problem is that Analytics Vidhya wants to see RMSE. They don't want to see accuracy. And so although we had a higher accuracy when I was using column transformers, I had a higher RMSE as well. It wasn't really high. I mean, it was only just minuscule. But the thing is, it's like when you're entering a competition and the competition says that they're going to be testing on RMSE, you want to get your score as close as possible to what they want. And because my RMSE was higher in the column transformers algorithm than it was here, I had to go ahead and go with this. So we predicted on our X test, and we made our predictions, and we set up and now what we've done is we're just looking at the sample to see what the sample is, because that's what Analytics VidHaya wants to see when we submit our predictions. And then we created our data frame. So output equals PD data frame. Item identifier is item identifier the variable that we had previously created. Outlet identifier is test outlet identifier. And item outlet sales is predictions. So we created a CSV file in that, and you can see what we've done. And so we've got a submission.csv, and I submitted that to Analytics VidHaya Solution Checker, and what I got was a score of 1,152.4888, and that was just a little bit better than the column transformer, because when I used the CatBoost with the column transformer, I got 1,174, which was 22 points worse. And since it was 22 points worse, I had to go ahead and go with this algorithm here, because that is what Analytics VidHaya wants to see. I just thought that I would mention that in case you want to take this algorithm and experiment with column transformer, because column transformer did actually give a higher accuracy, but it gave a worse RMSE as well. So if Analytics VidHaya had said that they wanted to test on the accuracy, I would have gone with the column transformer algorithm. So that concludes our presentation on this Big Mart algorithm, Big Mart